Everyone, today is January 22nd, 2019. This is the Transportation, Finance and Policy Committee. Just a couple of quick announcements before we get started. I just want everybody in the room to know that we are up against a hard deadline because we have to be on the floor at noon. So I will have to adjourn at 10 minutes to 12 just to get members an opportunity to get over to the floor. Today we are going to have an informational hearing on essentially automated trucking, and this is something that I've been looking forward to learning more about. The only other thing that I'm going to indicate is that if any members have a desire to have a future informational hearing, particularly in the area of transit, I'd be very interested to know what the future holds in the area of transit. With that, we are going to go to our testifiers. We're going to try and hold some time at the end of the hearing so that members would have an opportunity to ask questions. But with that, I think what we're going to do is just go right through the testimony and see what these folks have to say. So with that, who is going to lead off? Mr. Hausleden? Good morning, Mr. Hausleden. Welcome to the committee. State your full name for the committee, who you represent, and proceed with your testimony, please.
Yes. Good morning. Thank you, Mr. Chairman, members of the committee. My name is John Hausleden. I'm president of the Minnesota Trucking Association, and we're here today to help facilitate this informational hearing on automated trucking, and we're very excited. The trucking industry is big to Minnesota, and we've put together, I think, a very good lineup to help you understand some of the opportunities we have before us. Just two statistics from a trucking perspective: 68% of Minnesota communities rely exclusively on truck transportation for everything that goes in and out. So what we do with these trucks and the drivers that will be in them is going to be critical to continue to serve communities. And secondly, that 78% of all manufactured goods travel on truck in Minnesota. So it is the dominant mode. It will remain the dominant mode. And again, what we can do to advance safety, technology, and the driver's roles is going to be very critical to do that well. Our lineup today includes Brent Boyce, president and owner of Calhoun Truck Lines, who chaired our Automated Vehicles Task Force, Greg Trinan from Daimler Trucks North America, Stephen Boyd from Peloton, and Carter Foss from Cummins. So with that, I'll turn it over to Mr. Boyce.
Thanks, John.
Welcome, Mr. Boyce. If you would state your full name, please, for the record, indicate who you are here representing, and proceed with your testimony.
Great. Thank you, Mr. Chairman, members of the committee. My name is Brent Boyce. I'm owner of Calhoun Truck Lines. We are an intermodal trucking provider based in Eden Prairie, Minnesota. In addition, I'm also chairman of the Automated Vehicle Task Force of the Minnesota Trucking Association. To begin, I think it's important to stress at the outset that there is, and will be in the future, a high demand for professional truck drivers. We believe the professional truck driver will remain in the cab, but the role will evolve as automated technology assists with certain driving tasks. In some situations, the professional truck driver of the future may operate more like an airline pilot, handling city driving and using automation to assist in the middle of the run. I believe the driver assist technology will generate numerous benefits in the areas of safety, environment, productivity, efficiency, and driver health and wellness. I'm also excited about how emerging driver assist technology holds promise to attract new and digitally savvy people to the truck driving profession. We believe the primary role of the driver assist technology should be to enhance public safety by reducing human error and motor vehicle crashes. Trucking fleets desire to be actively involved in generating and evaluating driver assist technology data to demonstrate improvements in safety. The Minnesota Trucking Association supports policies that promote Minnesota as a testing ground for automated and connected driver assist technologies. The trucking industry relies on an interstate highway system that facilitates free flow of goods between states. As driver assist technology is developed, tested, and commercialized, It is critical that federal, state, and local laws do not create disparities that limit commerce and obstruct the successful adoption of these potentially safety and productivity-boosting technologies. We feel strongly that the regulation of performance and technical specifications of automated and connected driver assist technology should be solely the responsibility of the federal government. States should maintain their existing responsibilities that do not interfere with the flow of interstate commerce. The Minnesota Trucking Association encourages states to participate in creating and adopting uniform state laws. Minnesota should take steps towards removing existing barriers that may stifle innovation and deployment of advanced technologies. An example would be vehicle following distance as it relates to truck platooning, or more clearly defining what constitutes an automated vehicle. At the same time, state laws and regulations should neither require nor limit differing levels of automation. I'm personally excited to see how driver assist technology can enhance the role of the professional truck driver and make our roadways safer. Thank you.
Thank you for your testimony. I believe next up is Mr. Tynan. Am I pronouncing that correctly?
Yes, yes. My name is Gregory Trinan.
Trinan, okay.
Yes.
And indicate who you represent, Mr. Trinan, and please proceed.
Great. So again, my name is Gregory Trinan. I am with Daimler Trucks North America. We are a manufacturer of medium heavy-duty vehicles based in Portland, Oregon. And I'm here today. I'm on their advanced technology team, and honored to be invited to speak to you here today to discuss our efforts in developing automated driving for commercial vehicles, what the future of that technology may bring, and what our approach is in not only developing the technology that will make it happen, but the partnerships that will, with key stakeholders that will be required to make that a reality. We at Daimler Trucks have a demonstrated history of delivering new vehicle technologies at the right time. Not too early, not too late, but at the right time when the technology is mature enough for a broader application. And we've proven this time and again with new innovations, including safety systems and vehicle automation. In 2015, we drove the automated Freightliner Inspiration truck over the Hoover Dam to demonstrate the future, introducing our vision of this technology to the U.S. trucking industry. The launch of the Inspiration truck garnered worldwide media attention in 2015 as the first licensed automated commercial vehicle to operate on U.S. open highways in Nevada. The common misperception was that that Inspiration truck was a driverless truck, which it was not. Inspiration incorporated level 2 automated features and required a driver's presence to control the vehicle. It utilized radar and camera systems that are part of a collision mitigation and lane departure warning systems, plus the addition of an automated steering gear and advancements in the software algorithms that control the braking, acceleration, and the steering of the vehicle. The chief benefit realized with the program were several customer-focused technology gains that were immediately greenlit for commercialization. A number of the Inspiration truck breakthroughs are key building blocks that are part of the new Detroit Assurance 5.0 suite of safety systems that were announced a couple weeks ago and will be going into series production later this year. So 4 years ago, those technologies that were featured on the Inspiration truck were only a concept, and now they are becoming a reality. So 2 weeks ago at the Consumer Electronics Show in Las Vegas, we introduced the first SAE Level 2 automated truck in series production in North America with the latest enhancements to the Freightliner New Cascadia. The New Cascadia delivers Level 2 driving capabilities with the Detroit Assurance 5.0 suite of camera and radar-based safety systems. This new proprietary system marks a key milestone in Freightliner's relentless pursuit of industry-leading overall safety and driver experience. Previous iterations of Detroit Assurance over the past few years include adaptive cruise control, automating acceleration and deceleration of the truck. Level 2 automation means the truck is capable of both longitudinal, so again, acceleration and deceleration, and lateral, which means steering control. The Assurance 5.0 delivers on both of those capabilities. The lateral steering control is made available by Assurance's Lane Keep Assist feature, and the existing forward control experience with adaptive cruise control get us to Level 2 automated driving. This automated driving technology is considered an advanced driver assistance system, which requires the driver to stay engaged by keeping their eyes on the road and hands on the steering wheel. These features are used to augment the driving experience and making it safer for the driver and the public. I'll see if the little video clip works or not. Looks like it's not going to move. That's okay. So having a quick look at the prior slide, what was supposed to be shown here was the Assurance 5.0 adaptive cruise control feature, which automatically adjusts the truck's cruising speed to maintain a safe following distance from other vehicles in its path down to 0 miles per hour. In stop-and-go traffic, if the vehicle in front stops, the truck will also come to a stop and hold indefinitely. If the vehicle ahead moves under 2 seconds, the truck will resume moving at a safe following distance. Adaptive cruise control to 0 miles per hour improves safety, efficiency, and driver comfort by automatically decelerating and accelerating to maintain a safe following distance. This technology is especially important for maintaining a comfortable driving experience in congested traffic situations where repeated braking, accelerating, and resetting of traditional cruise control can lead to driver fatigue. So taking a look at our lane keep assist feature, that in combination with adaptive cruise control gets us to level 2. So when a driver switches on adaptive cruise, the system automatically engages the lane keep assist feature. This always keeps the truck in its lane by means of steering corrections carried out by the system. So when adaptive cruise control is enabled, lane keep assist supports the driver by using micro steering movements to keep the new Cascadia centered in its detected lane. The driver is still required to keep their hands on the steering wheel at all times. And if the driver does remove their hands, visual and audio warnings will occur after 30 and 60 seconds. So with the Assurance 5.0 suite of safety systems, it's not just about the features that get us to level 2 automation. It really is about the suite of safety systems and features that are designed to reduce accidents and save lives. For example, Assurance also includes an active brake assist feature, which is always on, automatically tracking the distance from the front of the truck to other vehicles in its path using bumper-mounted radar. With 5.0, the camera and radar signals are now fused, offering improved object recognition, so which means fewer false positives and more accurate capture of what's in front of the vehicle, and higher possible approaching speeds. So with the radar working together with the camera, Active Brake Assist now offers not only full emergency braking on stationary objects, but also moving pedestrians, which is an industry first. So we have a couple of other features involved in here, but given our time constraints, I wanted to also hit on the Side Guard Assist, which detects objects, including pedestrians and cyclists, in the passenger side blind spot for the tractor and the full length of the tractor, which is another industry first, delivering an audible and visual warning to the driver. So taking in combination with these automated driving features, we have a full suite of safety systems that are designed to improve the safety of the driver and the driving public. So our pursuit of safer roads doesn't stop there. 2 weeks ago in Las Vegas during the CES show, Martin Daum, the head of Daimler Trucks and Buses, announced Daimler will invest 500 million euros, or about $570 million, over the next few years to bring highly automated vehicles to the road within the decade. That means SAE Level 4. After launching Level 2 automation, we are developing Level 4 capabilities as the next step in delivering highly automated vehicles. We continue to develop technologies across the vehicle spectrum, automated vehicle spectrum, that make roads safer and help customers boost productivity. We know a majority of accidents are still due to human error, and Level 4 systems enhance safety in traffic thanks to a redundancy of systems and multitude of sensors and systems that never get tired or lose attention. Level 4 highly automated trucks also have the potential to improve efficiency and productivity, among other things, through higher utilization of vehicles. Adoption of Level 4 technology in trucking could help address the ever-growing driver shortage, which, according to the ATA, is expected to grow by 125,000 in the next 6 years. Automated driving will supplement the driver shortage, and job profiles will change with the potential for more attractive jobs, potential for more time at home, but the message is that drivers will still be in high demand. This technology will help society cope with the ever-growing volume of freight, thereby enabling further economic growth and prosperity. Global road freight volume is expected to more than double between 2015 and 2050, and we have to master this growth in a smart way, with highly automated trucks playing a major role. Frankly, we have a responsibility to investigate and test this technology, given the need to improve safety and to address the driver shortage and the increase in freight volume. The focus is not just on not on our urban areas for level 4 automation, but on highways, given wide lanes and one-way traffic with no cyclists, no pedestrians. So that's our initial focus for level 4. And from a global perspective, being that we're a global company, our focus is on the U.S. Due to excellent infrastructure here, homogeneous traffic flow, very similar speed limits for cars and trucks, and long distances. So it's again, our aspiration to bring this technology to the road in the next decade. So there are, however, key considerations in developing a truck with highly automated driving capabilities. The first, in order to realize highly automated driving, redundancy in safety-critical systems such as braking and steering is absolutely necessary. Second, we believe you need a full suite of sensors, cameras, radars, LiDAR at a performance never seen before. This technology will require massive computing power on board for the new world of sensor fusion, perception, localization, and more. But it's more than just the technology. It's one thing to create demos, but another to bring highly automated vehicles into series production and deliver to customers. We have to consider the impacts to you, our customers, the public, and drivers. For all, the aim needs to be getting from point A to point B and as safe and efficient and as reliable as possible. DTNA's highest priority is safety that is benchmarked through the reduction of crashes, fatalities, and injuries. And that is the #1 reason we are developing highly automated vehicle technologies. DTNA believes that by researching these technologies, this will accelerate the evolution of technologies that will save lives. Additionally, level 4 technology must also work seamlessly within our customers' operations and must help them run their business more safely and more efficiently. And we also need to essentially, the vehicle needs to encounter or be set up to encounter and make decisions in regards to various different situations it encounters through the road and various weather conditions, construction sites, and more. And the technology needs to be reliable 24/7. A fleet cannot afford lengthy downtime due to this technology, nor the cost of putting LiDAR sensors on a maintenance schedule like an oil filter. Those components need to be reliably perform for the next decade for more than 500,000 miles. So our technology needs to be 100% road proof. Testing and validation will help us draw upon our proven expertise and long history of commercializing safe, reliable, and fully integrated commercial vehicles. It's one thing to talk about safety and validation in respect to developing highly automated vehicles, but it's quite another to have demonstrated proof points and the investment in facilities to lend credibility to that talk. So as I mentioned in my opening slide, Daimler Trucks North America takes pride in introducing vehicle technologies not too early, but at the right time. And this involves thorough validation processes before we test on public roads. Our internal product validation engineering team utilizes our test track in Madras, Oregon to ensure new technologies will work safely and will hold up to the rigors of running hundreds of thousands of miles on North America's highways. So the validation process for level 4 automation includes extensive testing at that track. And through that testing, our stated goal is to place our first level 4 test truck on public roads by the end of this year in 2019. And through all this process, we announced in this past June the opening of our Automated Truck Research and Development Center in Portland. This R&D center will be a hub for researching, testing, and validating the technology that has the potential to save lives and make trucking more efficient. The R&D Center will furthermore be established as a center for co-creation where customers, suppliers, and business partners can provide input, ensuring the technology is calibrated for real-life applications. So in terms of partnership with key stakeholders, Level 4 technology cannot be developed in a vacuum. It will require partnership with these key stakeholders so that technology can be tested and eventually deployed safely in a way that meets the needs of all involved. We understand the sensitivity to the market with the role of the driver, and we are founding members of the Partnership for Transportation and Innovation Opportunities, whose charter is to understand the impact of new technology on jobs in the transportation industry. The PTIO is a recently formed group comprised of OEMs and suppliers that are building and testing on highly automated vehicles. As mentioned in the previous slide, we will work closely with our customers through a co-creation process to ensure highly automated vehicle technology can run safely and efficiently within their operations, delivering value to them. As Class 8 market leaders, we have established close partnerships with our key customers and have involved them in the development processes to ensure products fit their needs. Our electric vehicle co-creation process that we're undergoing right now is a great example of this, and we will initiate something similar with highly automated vehicles as well. DTNA is utilizing testing protocols to ensure the highest levels of safety and for the driver and for the driving public. And this effort includes actively interfacing and closely working with both federal and state governments to formulate safety testing processes for these vehicles. As a technology leader in safety and efficiency, DTNA considers it essential that it shares with regulators a deep understanding of our technology. Such collaboration will set up long-term foundation for creating regulation and policy that is beneficial for everyone. We are appreciative of the willingness of these government leaders and regulatory agencies to work with us and for their support as we share the same mission of reducing crashes and saving lives. And we look forward to continuing to work together as we strive for this shared vision. So to sum up, we understand that the impact on jobs and drivers in particular is a key consideration, and we believe that the role of humans is essential even for high levels of automation, as they're critical to ensuring the safe operation of these systems. While the driver's role could change, DTNA expects the driver operator to remain critical piece of the automation system as step-by-step transition to automated vehicles develops. Testing and validation are in our DNA at Daimler Trucks, and we have a demonstrated history of delivering technology at the right time. And we have made the investment in our product validation, engineering team, and testing facilities to make sure we are delivering technology that is safe and our customers can utilize to create value for their businesses. Public acceptance and confidence from our customers is also key. That is why our development process will involve key stakeholders as we move forward with co-creation. And through our partnerships with federal and state regulators, we need a regulatory framework established to set up a long-term foundation for creating policy that is beneficial for all stakeholders. And with that, I will conclude my remarks. Thank you.
Thank you, Mr. Trinan. Next, we have up Mr. Boyd. If you would identify yourself for the record, indicate who you are here representing, and proceed with your testimony, please.
Thank you, Mr. Chairman and members of the committee. My name is Stephen Boyd. I'm co-founder and vice president of external affairs at Peloton Technology, and we're a company that's located in Mountain View, California, but that has partnerships around the country, including here in the Midwest. Appreciate the opportunity to speak to the committee today and to have a discussion after our remarks about these technologies. And I'll go ahead and begin speaking a little bit about this. We, at Peloton Technology, we're working with driver-assistive solutions, so our focus, much in line with the comments that were made here before, is very much on empowering drivers and finding new solutions that improve safety and efficiency working with the drivers. Our solution uses connectivity to allow pairs of trucks to work together, but we start by making the individual truck safer at all times. We require best-in-class active safety on each truck, making that truck safer everywhere it goes. And then we use connectivity to link those safer trucks together, just pairs of trucks. And the drivers remain fully engaged at all times in the driving task, steering at all times, so it's level one and not highly automated. And as you've heard from the other speakers, we think that these kind of technologies are what are entering the market over the coming period of time. Highly automated solutions that don't involve drivers are far out. And what we really see here is an ongoing role for drivers in general, and in our solution, very much the driver's at the heart of the system. So you've already heard about the massive scale, of course, that the trucking industry represents. And here in Minnesota, John noted just how significant trucking is. In the U.S., there's major pain points that we try to address with truck platooning, including the over $100 billion in annual fuel cost that the trucking faces, which is still over 30% of their operating cost is fuel. In addition, another major pain point, crash cost, over $90 billion a year in U.S. crashes just facing the industry. And in general, these are the kind of problems that the industry struggles because typical fleets have less than a 3% profit margin. So it's difficult for them to make major investments and spend any more on these already expensive trucks. And that's why we try to tackle that problem by using efficiency benefits from our system to help them get better safety on each truck. The platooning systems that we're working on are built on decades of previous R&D by many companies globally and a number of research institutions in the U.S., Europe, and elsewhere. This is just a sampling in this map that shows some of the activity around the globe related to platooning. Many brands involved here in the U.S. and globally, and Peloton's partnered with a number of them. We have a large investor base of strategics, including over a number of major Fortune Global 500 companies, including 10 Fortune Global 500 companies, notably UPS, Volvo, Intel, BP, and others. As I said before, our focus is to improve the individual safety of each truck at all times using state-of-the-art collision avoidance, lane departure warning, and disc brakes on the tractor. That makes that truck with that spec the safest truck on the road. We talked about the importance of, we all agree on the importance of improving truck safety, and these collision avoidance systems are now proven by multiple studies to dramatically reduce crashes. Even the earlier versions of these systems, the newer versions of these systems are even more effective, fully braking a truck to a stop if there's an obstacle, full collision avoidance. One unfortunate thing is that whereas there have been some efforts to try to mandate these safety systems and require them to be on trucks to improve safety, in Europe, actually, in November 2015, collision avoidance and lane departure warning was mandated for trucks. They've seen a dramatic reduction in crashes and savings for the industry there, improvements to highway safety in Europe. Now, in the U.S., no mandate has proceeded. However, solutions like truck platooning can accelerate faster than the market, bringing these safety systems onto trucks. So our system takes that approach. We require these best-in-class systems, and that's the heart of our Platoon Pro system, is helping drivers, improving teamwork, improving safety and efficiency tied to that active safety. So our approach is about that connected driver teamwork, cooperative between those two drivers, and we're linking the active safety systems between these trucks. Essentially, what this is cooperative adaptive cruise control. The experience for the driver is akin to you in your car driving with adaptive cruise, where you've got radar looking ahead, and you've got connectivity, though, between the trucks. The real power here is that the V2V, the vehicle-to-vehicle communication, allows instantaneous communication between those trucks. Thus, the front truck, once it detects something ahead and begins to slow, the follow truck immediately does the same. So today, the trucks are all stacked up together on the roads. You see them all the time, often driving too close, without safety systems, without driver-to-driver communication, without linked safety. We're trying to address that reality of the roads today. They're not perfect roads. This can help improve the orderliness of the trucks on the roads today. The focus of our safety and of our approach is, as I said, on driver assist, and thus the levels 0 to 2. We're at level 1 with the drivers steering at all times. And let's see if the video can play here. I think we found that the videos weren't really playing, is that right? Guess not. So skipping ahead, this sort of summarizes our overall framework here. Level 1, automation, only pairs of trucks. We're partnered with major OEMs in delivering jointly validated, safety-validated solutions. Our system improves driver teamwork with a direct radio connection between the trucks along with a video connection so that the driver in the follow truck has a window through that truck ahead, essentially, a video view of the driver ahead. And you see this in the videos. We'll provide the videos to the committee so you can review these videos and understand more about the reality of the system as you can see it in operation. We also limit operation of these systems to multi-lane divided limited access highways, so only appropriate roadways can use the system. We do that using geofencing so that the driver is unable to activate platooning unless within an appropriate type of roadway. This is a view of that shared video perspective the follow driver has a view of the road ahead. The follow distance for these trucks is on the order of 50 to 80 feet when we platoon them. That still leaves room for vehicles to cut in. The system also automatically detects vehicles if they cut in and make space. So that adheres with, of course, normal operations on the road. That connectivity, the drivers are then able to reconnect and platoon, reform the platoon after a cut-in occurs. This image here shows more of that. This is also in the video that you'll be able to view at another time. So we, again, have geo-fenced, and we prevent use of the system other than in appropriate roadways, so multi-lane, divided, limited access highways. We also monitor weather and traffic and geo-fence out actively for that. The cloud-based system, our Network Operations Center, is monitoring the safety of the trucks and is matching them up so that within the same fleet, a pair of trucks is able to link up. And a key part of that is we always put the heavier, longer stopping distance truck in front. So intelligent ordering of the trucks is very important as well. The data from our system is helpful not just to the fleets and the drivers, but also to highway operators, so that these trucks are out there, they're highly censored, they're gathering information about the road and weather conditions, and this can be provided back to highway operators to improve the awareness about the road and to help other motorists. Vehicle-to-vehicle communication, we use the 5.9 gigahertz DSRC, dedicated short-range communications spectrum, to allow for this V2V connection between the trucks. It's been set aside by FCC in a partnership with DOT for many years now in place, and now DSRC systems are finally entering the market. At Peloton, we're one of the players bringing this into trucking. So this slide right here represents how we get that closer following distance. It's because we're eliminating perception and reaction time as well as brake lag. You can take that following distance down from perhaps 200, 300 feet for trucks. That's practically what the distances they may be at. Sometimes they're closer. In Minnesota, you have a rule that requires 500 feet following distance. However, that may not be heavily enforced. Typical distances are probably more in the order of 200 feet. We bring that down to between 50 and 80 feet to allow better drafting and aerodynamic efficiency as well as that connected safety. There's 3 videos in this presentation, and hopefully you'll be able to view them. The one I was going to show there would show emergency braking, how the trucks are able to brake extremely hard and maintain a gap throughout that process. So teamwork and our drivers are key to what we're doing. Our drivers not only help us with our testing and validation work, but of course they're part of also making sure that the design is driver-centric, that it works well for drivers. They've been a key part of our operation, and they're at the heart of our company. This video that you'll be able to view later shows the view from the follow driver's perspective, the way the drivers work together, the fact that the follow driver almost quarterbacks the situation working with the front driver. It's not like the driver in the back is detaching and has a lighter workload. They continue to work together, and there's a lot of teamwork, and you can see how they make lane changes and how they work together, navigating the road, improving upon the status quo out there where trucks are not communicating with each other, are not having connected and active safety on each truck, and don't have these tools. So our approach, as I mentioned before, is to jointly integrate and validate, safety validate with the major players. We're working with a number of these OEMs, PACCAR notably, and others, and our approach is to use proven methodologies for automotive safety and functional safety validation to deploy these systems onto the roads, robust process of track, and then road testing, working with our partners. So the benefits, independently validated fuel economy benefits of platooning come in on the order of 10% for a follow truck and about 5% for a front truck. This unlocks a lot of great value that then helps those fleets then bring on these better safety systems. And you get an ROI for a typical fleet, typical truck in under 1 year payback period for typical trucks that are operating at about 75 to 100,000 miles a year. Jumping ahead a little bit here, we have solid demand from a number of top fleets, including these, a number that operate here in this region. And our approach to deployment is same fleet. So platooning will be used by the same fleet within its own operation. At a later phase, some fleets may choose to cross-fleet platoon with other fleets that they choose to work with. That's a later stage. So for now, it's same fleet. And another important part of this is that we're only deploying this onto new trucks. So you're not going to see old trucks retrofitted with this. Only very recent model trucks might be upfittable, retrofitted, but typically it's going to be new trucks, which is part and parcel to having that active, better active safety in each truck. So we're not going to see old trucks out there that would be using this. The main use case is same fleet, dedicated routes, hub-to-hub routes, within the same fleet drivers operating these systems. There'll be later solutions, variants on this that can work with other types of fleet operations, but this is the initial use case that we expect. So that's the operating environment there. This map shows the U.S. highway interstate system. Here's interstate highway system, and this is the major multi-lane divided limited access highways in the U.S. that would be major operational areas for truck platooning. We geofence out, though, areas where the topography is not suitable or other conditions are not suitable. We also geofence out construction zones and other such things. Federally, because truck platooning is driver assisted, and because at the heart of it is a following distance matter, it's a state matter, state regulated matter, no federal barriers. In fact, the federal government in their guidance 3.0, recent policy guidance related to connected and automated vehicles, they encourage states to remove barriers for truck platooning. This is sort of the landscape of the regulations across the U.S. The states in gray here represent those where the following distance rules are reasonable and prudent discretionary standard. In those states, some states have determined that they can allow for truck platooning with no change to law. No change to law at all, simply administrative allowance. In the orange, you'll see states then that have a numeric minimum following distance. Minnesota is one of those with a 500-foot rule. In those states, we expect legislation is needed. So far to date, we have now 18 states that allow full commercial deployment of truck platooning, and a growing number of them are looking at this further. We expect during 2019 a number of other states will move to make full deployment allowance, and we're looking forward to further discussions here in Minnesota about what may be possible here, working with our partners. And as part of our work, we've also done a number of demonstrations in a number of areas, Michigan, Florida, where we've worked with the states to identify with them and have their highway patrol and DOT ride along with our systems to understand more of these. Some studies have come out of this work, including a study out of Florida, showed no new infrastructure is required, and no communications infrastructure is required either for this, which is very important, that for vehicle-to-vehicle communication, all systems are on board the trucks. You don't need to have any other kind of surrounding infrastructure. Outlook ahead for Peloton and for truck platooning here in the U.S., we're bringing systems already into use in Texas. We have fleets that have already begun running freight in Texas, and we're working with a number of other states around there to expand that over the coming year or two. In Europe, all 6 OEMs have developed platooning systems, and a number of them have begun fleet programs with them, including MAN Trucks and Scania. There's a number of other programs in Asia and Australia that are kicking off. Peloton has a project that's ginning up in Australia as well. And so robust activity continues over the coming period. We expect that main activity will be out of Texas and the Southwest initially, but as other states come online to allow truck platooning, we expect that fleets and OEMs can make plans to bring these things into operation in other regions. Some of this maybe is best covered in subsequent discussions, but this is just an example of the following distance law that's relevant here in Minnesota with this 500-foot numeric minimum distance. And this is an example of a sort of basic approach to adjustment to the vehicle code that would be akin to what other states have done. We recognize that there's some draft legislation that's been looked at in the past that came out of the Connected and Automated Vehicle Task Force last year, and that there may be some further discussions of this nature. And we look forward to working with the Trucking Association, our partners here in this region, and this body and the executive branch here to look forward ahead to what may be possible regarding truck platooning here in Minnesota. So thank you very much. I appreciate your time.
Thank you very much, Mr. Boyd. I just wanted to tease you a little bit coming out of California. I suppose you were a little shocked when you got here.
No, I enjoyed it. I grew up in Pennsylvania
and
Michigan, so I can handle the weather, but thank you, sir.
Thank you very much. Next, we have Mr. Foss. If you would state your full name, please indicate who you are representing and proceed with your testimony.
My name is Carter Foss. I'm here with Cummins, the Electrified Power Business Unit. I'm going to talk to you today about our vision for electrification into the trucking market. Yep. Okay. So a quick background on Cummins and specifically the Electrified Power Business Unit. Cummins has been focusing on hybrid and electrified developments for over a decade now. But just in 2017, it was kind of officially an electrification business unit that was launched. Later that year, in the summer, we announced a partnership with Gillig to deploy and develop a transit busing system for hybrid and electric technologies. Later that year, in August 2017, we unveiled a demonstration vehicle, which we called EOS, which is a heavy-duty semi, fully electric vehicle. Again, just a demonstration of our technologies in the electrified space. In October 2017, we made the first acquisition of Brammo, which is a battery module company focusing on lithium-ion technology that was out of Talent, Oregon on the West Coast. Primarily focused on building, electric motorcycles, power sports vehicle equipment, and being able to stream those into high voltage battery module packs. As well, they had a wonderful range of software and hardware components to control the safety and ultimate performance of these vehicles. Moving into 2018, a second acquisition was Johnson Matthey Battery Systems out of the UK. They focused on high voltage systems and large pack, again, lithium-ion battery module development in the high voltage space for the large and heavy-duty on and off highway trucking market. And then officially in 2018, we announced ourselves as the Electrified Power Business Unit to give our space within Cummins to have the dynamic capability to use resources as needed for our developments. And then the third and final acquisition that Cummins made was Efficient Drivetrains Incorporated, a company out of California. They are a system integrator of electrification, so they can take a full, say, Class 3 to Class 8 large vehicle and fully electrify it. So not just put batteries in it, but full controls technology, electrify steering, cooling, braking, all the other subsystem components that are required to do this type of integration. So as you can see from the map, we have kind of a global footprint from Electrified Power Business Unit ourselves. We have just over 300 some employees within EPBU. Almost 2/3 of those are purely engineers focused on our development and technology right now. Hundreds of patents in this space, and we have almost 9 million miles on our technology in vehicles. So we see 4 keys to adoption. Technology, of course, being a big one. Lithium-ion chemistry, cell technology, whether it's power electronics that help control that. The software is really important to making any system viable for what we have today. Regulations, of course, laws, regional focus, as well as subsidies to help companies integrate these technologies, whether it's today or tomorrow. Infrastructure readiness, of course, is another big piece. Think of charging, how you charge these vehicles, whether it's vehicle to grid, vehicle to vehicle. Cummins specifically will not play a direct role in outfitting charging systems, but we are going to enable the enablers, per se, with how we will be partnering with industry leaders doing that type of infrastructure work. And then, of course, the total cost of ownership. At the end of the day, someone has to buy these products, and whether or not the duty cycle, the specific application, all fits with what the technology costs today. So electrified technology is coming, and Cummins is readying ourselves. We see about a 20 to 25 year transition period from what we use today. So there's kind of phase 1. These are our early adopter programs. Sociability needs are kind of the big drivers. Think of air pollution, noise pollution. Hybrid and all-electric technologies can really solve that problem. And there's certain applications, if you look at the map, you look at material handling, you look at port or distribution applications, vehicles that are limited to, say, 25 miles an hour or lower, transit bus, school bus applications, urban delivery vehicles. All these have very short, repetitive routes where the duty cycle matches the current technologies and capabilities of it today. as well as the drive cycles I talked about. And there's a lot of subsidies that we know of that are supporting transit bus and school bus integration into different urban areas. So phase two, as we move on, improved technologies, it's going to, wider regulations are going to support more and more vehicles being able to use these technologies. The duty cycles will start to make more sense as technology improves with larger capacities within batteries, better chemistries from the lithium-ion space. Subsidies will still, of course, exist. And then, of course, as the infrastructure continues to expand, it will allow vehicles to, from other applications that may have different distribution sites and charging sites that aren't quite as feasible from a localized region to start making more sense as well. And then phase three, this is really where the viable economics really kicks in and makes sense. So not just for businesses with subsidies and incentives to move to electrification, really the consumer market as well will be incentivized purely from the economic standpoint to accept lithium-ion hybrid and electric technologies. So powertrains that we have today, of course, diesel, Cummins being a big leader in diesel technology. Heavy-duty long haul is a major application where this is still relevant today. And even Cummins, we believe, for decades to come, diesel will still be the major player in this long haul market. With the duty cycle that they run, the miles that they run per day, the technology and infrastructure just isn't there today or even in recent decades to allow that to move out. Natural gas. So again, more regional haul applications. There's certain markets right now, especially the refuge truck, where they have economically priced natural gas, and it makes the whole TCO equation makes sense for them. And then there's kind of a hybrid space. So this is lithium-ion battery modules mixed in with either natural gas or diesel engines. Think of a utility truck where it still needs to drive on the highway at high speeds or get to a job site that may be out in the country. That once they get on site, there may be regulations that limit their diesel emissions. So this is a perfect example where they can turn off the prime power diesel, turn on the batteries, and work with their full tool and boom arm operations without the need for that diesel. And then, of course, full electric transit bus. That's a big market right now. It's an early phase one adopter. Again, it's able to use the technology and is incentivized today. So Cummins has a powertrain of choice. We are not going to just push diesel. We are not going to just push battery electric. And we think these markets are going to play together with us rather than battle each other. So again, it makes sense for some markets to have diesel, have gasoline, internal combustion engines. For some applications, hybrid is what's most appropriate, not just now, but also in the future, to have that prime mover as well as full electric capability. Then, of course, battery electric technologies within the vehicles. And then fuel cells, of course, whether this is prime fuel cell or fuel cell hybrid with some battery module system. So Cummins has the power to deliver this. We've been around for 100 years almost now, and that gives us a lot of, we've had a lot of time to develop our technology and really understand the trucking market on and off highway industrial applications. With technology comes great advancements in safety and reliability without having to downplay our quality of product at all. Powertrain of choice, I've already talked about. Capabilities across applications. So again, working in this space for so long, we understand there's so many different market niches just within trucking or on or off highway. We've dealt with so many of them and succeeded at so many of them. So we have a deep application level understanding of what powertrain truly does make sense today and tomorrow for these different applications. Ability to achieve scale, again, without sacrificing quality of our product. We produce over a million engines a day, diesel engines, a year, and 15 million in the field today. So we know what it takes to achieve scale, not just in diesels, but we're going to take that into electrification into the future. Security of supply. So this is difficult you see a lot of startups in electrification right now. It's difficult for them to maintain secure supply. Sometimes big suppliers don't take them seriously. Cummins, again, with our presence in the market, we can have that partnership with strategic suppliers to ensure lithium-ion chemistry quality, and that we will be around for our customers for years to come. And then a global footprint. We have thousands of distributors around the world that we're able to not only work with to understand their direct needs, but as well distribute our product in a logistically manner that makes sense. So we have a huge focus on investment. There's roughly 60,000 employees within Cummins, and about 10,000 of them are engineers focused on technology advancement throughout Cummins. We spend about $700 million a year on powertrain innovation. In Cummins, for Electrified Power Business Unit alone, has committed $500 million over a 3-year period, particularly just to develop electrified technologies. So we're in the middle of that period right now. And again, pulling in acquisitions with inorganic growth of the Brammo Johnson Matthey Battery Systems as well as EDI has allowed us to expand our workforce, our technology advancement, and really become full, not just product, but full system integrators of that technology as well. So just a quick background of what the products that Cummins will offer. So again, to create a full battery system, you have to start with cell materials. So we have an electrochemistry team. We do not specialize in building cells, but we understand the chemistry, the mixtures, the construction of the cells to work with those suppliers and specify exactly what we need for any application. So we procure cells, we buy cells, and we build battery modules, battery packs. The battery management system is the brains that controls all the performance limitations. This is also the safety of the piece. So this is 100% controlled in-house. We do all the hardware and software development, which gives us great control to that piece, performance and safety. Thermal management, again, Minnesota is a cold environment, one place where keeping the temperature of those cells in optimum range is really important. So it's something we have a lot of experience in. So we take those packs, battery modules, and combine them with vehicle power electronics, controls, maybe an engine if it's a hybrid application, gearboxes, transmissions, different wirings, coolings and accessories to create full system integrated pieces and full vehicle offerings, not just component level. So again, Cummins, we believe we're going to be a leader in the markets that we serve. We're not just, again, system integrators. We do that, but we spend a lot of money and a lot of time and a lot of resources developing our technologies, being deeply integrated in what we do to make sure we have the best product, the most quality product, the safest product for the market and the timing that it is. Thank you very much.
Thank you, Mr. Foes. At this point, we are going to go to questions for members. I'm going to ask the pages if they would bring up a couple of chairs so all of our presenters could come up. And I'd invite Mr. Boyd. I've got a question for you, if you could get yourself in front of a microphone. I'd like to ask a question, Mr. Boyd, about the platooning that you spoke of. And it's going to be kind of an inartful question, but I'm picturing a series of 18-wheelers going down the highway, effectively creating a barrier that would prevent other motorists from getting around them because maybe they're too close or, you know, whatever the case might be. And so if you could explain a little bit in more detail how this platooning system would work from a standpoint if motorists want to get around them, and also what happens if a motorist gets in between these trucks that would maybe interfere with the radar that they are using to platoon with. Mr. Boyd.
Yes, sir, Mr. Chairman. So a key element of this is that we only allow platooning on multi-lane, divided, limited access highways. So in any operating environment where platooning would be occurring, there's a passing lane always there. In addition, this is basically built, this is trying to create more orderliness in comparison to what's happening today on the roads where the trucks are out there stacked up without connectivity between them, without the active safety, without the driver teamwork. So we're trying to address the status quo. The trucks are out there today. So motorists will be able to pass in that other lane. Sometimes there's two lanes, sometimes there's three, but there's always that other lane. So these trucks are moving, at proper speed, at the speed limit, working together, just pairs of trucks, and they aren't obstructing both lanes by any means. In addition, in terms of the vehicles cutting in, the system will detect a vehicle cutting in and make space for that vehicle, separates the platoon out. And so there's no issue if a motorist needs to exit the highway and chooses to do so between the trucks or enter the highway. The system adapts to that. There's a video that's in my presentation that shows some examples of this kind of interaction and how the drivers also work to anticipate as they approach interchanges, vehicles coming on. They may separate the platoon proactively. They may lane change to make space. So this represents no additional obstacle to traffic flow. In fact, we think it improves upon it.
So, Mr. Boyd, if a vehicle gets in the gap, the system is going to recognize the vehicle that is not involved in the platoon, while at the same time recognizing the vehicles either before or in front of or behind that are involved in the platoon. Is that correct?
That's correct. And the reason that we're able to do that is we're using not just the radar, but also this 5.9 gigahertz vehicle-to-vehicle communication that's uniquely identifying the two trucks. So the two trucks are aware of each other over that spectrum. There's the radar between the trucks. So a vehicle cutting in, the radar detects that vehicle, makes space. At the same time, those trucks are still communicating over that DSRC spectrum and are aware of each other's position at all times. We also look at wheel speed. We look at high-resolution GPS. We have multiple ways in which the trucks stay aware of where each of the trucks are, as well as observing the other vehicles around using other sensors.
And a final question, Mr. Boyd. The platooning technology is available right now. Is that correct?
Correct. We were moving freight today in Texas.
Thank you, Mr. Boyd.
Thank you, sir.
Senator Osmic.
Thank you, Mr. Chair. For Mr. Boyd, I've asked this question about autonomous vehicles in general. So I have two questions. One is latency. If our computers are wonderful things, and there are sometimes issues where they can't compute fast enough, or they, and many people will say, freeze up on us. What happens when the system moves in? The onboard system has a latency issue. Part two of that is, when you're connecting two or more vehicles together, one vehicle may have a latency issue, or you may have a latency issue with going to a network itself, which, a wireless network would be an example of that. What happens there? And then the last question is, we change speed limits here in the legislature sometimes. Even locals will change speed limits, but those are much more unlikely that would have an effect, because those are not two-lane freeways, basically. How does this system adjust for changing right now? Just right now, you go from 55 to 75 to 65. How do the computers on board deal with that type of changing environment?
Good question.
Is this a question for Mr. Boyd?
Yeah.
Mr. Boyd. And you have to excuse me, I have to recognize who is speaking so the record knows who is speaking. Otherwise, it gets kind of confusing. Mr. Boyd.
Thank you, Mr. Chairman. Great question. I think there's three parts to that. So a key part of this to recognize is that we are not going up to the cloud for any kind of real-time safety communication between the trucks. It is point-to-point between those vehicles. That's why we're using this V2V, vehicle-to-vehicle communications dedicated spectrum, is to provide for that super fast connection that's just point-to-point. So there's no delay going through the cloud related to that. We also have an additional computer on each of our trucks that's monitoring the health of the system and the other ECUs. If there's any delays that are detected in the operations of any of those units, any dropped packets, connection loss between the trucks, we have the natural fallback approach that we dissolve the platoon. And we err on the side of being very conservative on that and dissolve whenever there's any kind of possible issue. So that's the beauty of it, actually, is that we can dissolve the platoon. The active safety is remaining, continuing on those systems. The active safety systems are separate systems that we're integrating to, and they have their own ability to take over if there's any delays or failures anywhere else in the system. So that's how we handle those elements. I think that mostly addresses the latency question. The only use of the cloud is for our monitoring over time of the truck's position using cellular. And but on board the trucks are able to do everything they need from a safety critical standpoint right there, point to point between the trucks. The last question was on speed. So we use a mapping approach similar to Google Maps and other tools that I'm sure you all use. And we're, with that, tracking where the trucks are and what the speed limit or other rules are pertinent to that area. And we're only allowing platooning on multi-lane divided limited access highways where the speeds don't tend to change as much. But we're observing those, and the trucks then are adjusted to the proper speed for that area. So this system actually improves speed compliance against the status quo. Thanks for your good questions.
Senator Dibble.
Thank you, Mr. Chair. Unfortunately, I stepped out at the key moment to greet some folks in the rotunda, so my question may have already been discussed, and if it has been, just tell me you'll bring me up to speed later. So it might have been mentioned that the Connected and Automated Vehicles Task Force is meeting on Thursday to talk about a couple of legislative recommendations.
Senator Dibble had not been mentioned.
Oh, okay, so that's happening on Thursday. I don't think it's any secret. That's a part of their report that they were going to bring forward a couple of proposed pieces of legislation, one of them having to do with testing of automated vehicles. The other is allowing for platooning of trucks on our highways. And the draft language is going to be discussed by the task force on Thursday. So coming to the legislature near you very soon. I'm actually looking at the draft right here. My question is, so there's some experience with platooning in Texas, right? So a couple of questions. One is that just happening on the open roads? Number one. Number two, what has been the response of the driving public to that? Has it been, are people aware? Do they know how to interact with the platoons? Has there been an effort to educate and engage the public so that they know that these platooned trucks are running around their freeways so they can keep their eyes out for them and they know how to respond and react to them? And should this legislation include some provisions for public awareness, engagement, awareness building, and training, et cetera, so they know how to respond and react when they see these out on the freeways, should a legislative proposal come forward and be passed into law?
Mr. Boyd.
Thank you. Thanks for the good questions. Yes, so we are operating on the roads in Texas today and in a number of other states, Arizona, in California. We have a testing allowance in California. There's a new bill being developed in California this year that may lead to some steps beyond that in terms of maybe some limited commercial deployment allowance. But in Texas, this is where we have most of our activity. Now, this is not large numbers of trucks, and we would expect that here in Minnesota and other parts of the region, this is not a situation where if a bill is passed that suddenly there's thousands of trucks in operation. This is a solution that's being brought forward by a few major fleets that want to try this out and are aiming to use it for certain parts of their regional haul operations, not every truck and not every truck in the road by any means. What we have found is that motorists don't notice that the trucks are platooning because trucks today are often traveling very close already. So these trucks don't look that different. We were in Florida. We ran for 4 days straight on the Florida Turnpike from Orlando to Jupiter with Highway Patrol on board and with DOT observing. And their observation was that the motorists didn't even notice anything different about these trucks and that there was no negative effects to the traffic around them. We certainly recognize that as the numbers of trucks would increase using this solution, that public education is important, and certainly we'd love to, work with you and and the body here regarding any relevant public education elements that could be meaningful. But to date, we've not seen an issue on that. But those are good questions, and love to work with you on this.
Senator Kiffmeyer.
Thank you, Mr. Chair. Very interesting presentation. We have these driver assist technologies now in the new cars that are coming out, and I think the folks around are more comfortable by seeing them more around, and they are a great boon and a great asset to that, and I'm sure it is for trucks as well. Probably one of the issues that I think I run into frequently, though, is two trucks driving alongside each other, and a bit of frustration and some road angst coming from two trucks alongside each other, and the whole speed and all of that. So how would these kinds of vehicles handle that situation where you've got a lot of technology going on, but that's the kind of situation I see frequently, having a lot of frustration from folks around that. If you could address that. Then the second one is, you mentioned the regulatory framework. So what is it that is an issue for you today? Is there anything? What is it that you see for the future that would be necessary regulations only to the sense that it frees you up to do it, but doesn't tie you up so you can't? There is that balance in regulations there, and if you even need it at all. So if you might speak to those two issues.
I'm not sure. I'm thinking that maybe Mr. Trinan would be on the first question. I'm not sure about the second. Mr. Trinan?
So regarding the first question being the vehicles side by side and some frustrations in terms of that, so there isn't necessarily, specifics regarding that. I mean, the driver's technically, is still in control of the situation and is operating in adaptive cruise control, and so it really is, up to the driver in terms of, completing the pass of the vehicle in the right lane. So I hope that answers your question. So from that perspective, you're in adaptive cruise and you're in the lane keep assist mode. The driver, again, still has to recognize and be totally cognizant of the driving situation. And so that doesn't change. And sorry, what was the follow-up question?
About the regulatory framework.
Senator Kiffmeyer.
How much is enough? How much is too much? Are there things right now that keep you from functioning with driver assist vehicles and everything that you want to do? Or is there regulations that you think would be helpful to have to make sure there's a level playing field for all trucks in regards to their operation with driver assist or the future?
Sure. From a regulatory framework, ensuring that, testing protocols and testing processes are laid out clearly so that they are completed in as safe a manner as possible, so that we're all, completing the mission of reducing accidents, and and that goes for testing the technologies as well. Ensuring that from a level 4 perspective that that there's things like a safety driver in place, and that the redundancies are in place to make sure that if one part of the system is not working, that the core functions are still operating and the vehicle is still able to operate.
Mr. House,
so that's part of our work with the Research and Development Center in Portland. It's not just a series of engineers, but we have folks on the team as well that are interested in engaging with you guys and having those conversations directly, and partnering with you guys, not just with regulators, but with our customers, with unions, with other interested parties as well in crafting that.
Mr. Hauslein, you had a comment on Senator Kiffmeyer's question.
Yes. Thank you, Mr. Chair. Senator Kiffmeyer. One of the things that's interesting, obviously the trucking industry is very interested in this. Every fleet looks at this through the safety lens first. And so from a regulatory perspective, it's like, who's going to regulate the safety of this? Mm-hmm. And as Mr. Boyce said, we think, regardless of what you may think of the federal government on this specific day, it does a pretty good job on the vehicle safety piece. National Highway Traffic Safety Administration, those groups that validate that the vehicles are safe, that whether it's the tires, the pressure, all of all of that stuff we think is appropriate from a federal perspective because we travel interstate. So we don't, what we think would be not helpful is if state governments tried to get into the technology world of, well, this technology is acceptable in this state and it's not in this state, and then the challenges of validating it. So there would be that point. But secondly, we do think the states still then maintain their traditional rules. We permit and license vehicles. We permit and license drivers. We enforce the roadside rules. So we think that kind of partnership is what's appropriate. So it's, I hope that's helpful.
Thank you, Mr. Chair. It is helpful, but I think licensing, when you mention, especially in our particular committee, that is an area that we may do a little more follow-up, because those are unique licensing situations, unlike the traditional total driver control for the most part. But that's good for now. Thank you, Mr. Chair.
Thank you, Senator Kiffmeyer. Senator Anderson.
I'll pass.
Senator Little.
Thank you, Mr. Chair. I just have a couple questions about some liability issues. Would you agree if the technology fails and there's damage to a person or property that any maker of that technology would be liable as well for those damages?
Who would like to answer Senator Little's question?
So I can't necessarily
Mr. Trent.
comment on that in particular. In particular, as we start to develop and do research on highly automated vehicles, I mean, those are some of the key questions and some of the reasons why we want to partner with our key stakeholders and with our regulatory, with our government partners as well, to determine the answers to those questions. And this is something that is, developing level 4 automation is not something that's going to happen overnight. And we recognize, I mentioned trying to put a series production truck on the road in this decade. Part of the reason is not only testing out the technology, but is, working with our stakeholder partners to determine the answers to those questions.
Senator Little.
Thank you, Chair. And then my other concern is for drivers themselves. Because if there is some sort of failure in the technology, what kind of impact would that have on a truck driver's record and their ability to get a job in the future?
Mr. Traina.
Great question. So that's not something that's been determined quite yet. And back to the Senator Kiffmeyer's question about some of the regulatory questions that will come up and will be part of that discussion. That is absolutely something that will need to be addressed. But at this point, it's too early to answer that.
Senator Carlson.
Thank you, Mr. Chair. I have several questions, but some of them probably would be suitable for individual consultation. But one that I'll start out with Mr. Boyd, because he has been speaking quite a bit lately, and that is I think you mentioned 80-foot separation in the platooning, and I would imagine that that's compromised with fuel savings and perceived safety and real safety. And I guess what I'm thinking is that you could have it 10 feet. You could have it something that's really, really close. And I'm wondering if you've evaluated the trade-offs with that 80 foot, because that might even be more dangerous than 10 feet. If you let a car get in between there, you can't control the human reactions, and the human reactions could cause more problems than just keeping them out of there. And 80 feet is actually longer than a truck vehicle. So, it would be. I'm wondering if you've looked into that might be something you still need to work out. And I think you did say that other states have the reasonable definition, so maybe we could get closer than 80 feet.
Mr. Boyd.
Yes, Mr. Chairman. Thank you, Senator. The range of operation that we're looking at, it's in the range of 50 to 80 feet. At those closer distances, we do see lower incidence of vehicle cut-ins, naturally, but sometimes they occur. We, recognizing that and recognizing that in general we're putting trucks together that have sometimes different loads on board, different weights, we want to allow some variation in their braking and stopping distance. So we aren't looking at deploying at very close following distances in order to allow for the flexibility to put various trucks together. Certainly, it's possible further in the future that more highly automated systems might be able to operate closer together, perhaps. But we think that this, in that range of 50 feet or so, that actually deters cut-ins, but provides for the flexibility to put various trucks together. Now, to be clear, we're only allowing, and we in real time measure the weight of each truck. We only put together standard loads, so not over-dimension loads, and we run with standard trailer configurations as well, 53-foot dry vans, double 28s. So that's how we're looking at the following distance matter.
Senator Carlson.
Yes. Thank you for your answer. Another question for Mr. Trinan from Daimler. Daimler obviously comes from Europe, and I'm wondering two things. One is, can you give us a characterization of how you're working with the European part of your company or other people in Europe? And you mentioned that FCAM was mandated in Europe, the collision avoidance system. And when was that done? And has there been studies on how that's contributed to safety over there? And then I'll keep asking the questions here. Was that to what level of trucks was that? Was that only to the truck and trailers, or was that to smaller trucks? And is that something that's continuous across the borders of all of the European Union?
Mr. Trinan.
I think you made it.
Yeah, I think I brought that
Boyd?
stat up. Mr. Chairman,
Go ahead, Mr. Boyd.
I think I brought up that stat or that information. So that was in November 2015, and it was an EU-wide European Community regulation applying to all new Class 8 trucks. I believe it does apply to some of the smaller class trucks down to 6. I'd have to verify that and get back to you to look at how wide the rule was on that. But in Europe, they've had for quite some time a real goal to get these safety systems out there. A number of the countries have a zero deaths goal, which a number of states have begun pursuing that here in the U.S. No question that getting these active safety systems on the vehicles has dramatic results. And there have been some initial studies. I can find some of those and send them to the committee. There were some earlier studies here in the U.S. that just looked at voluntary deployments of active safety with fleets like Conway and others, Conway now XPO. And these showed tremendous reductions in crashes, 70–80% reductions in incidents. So it's an important area to look at. We're trying to use a market force method of a means to incentivize fleets to deploy safety and to pay for it. But there could also be some interesting solutions that could be made standard. I know a number of the OEMs like Daimler have already made standard these safety systems. So,
Yeah, absolutely.
Members, one moment. I just want to indicate, members, that we only have a couple of more minutes. I've got 2 more senators that would like to ask a question. It's up to you, Senator Carlson. Do you want to yield or do you want to ask a follow-up?
I have a couple of minor follow-ups, if I may.
You may.
Okay.
Senator Carlson.
One is that, when we talk about the follow-up legislation that needs to happen, per Senator Kiffmeyer's statements, we're sloppy with our rules in a lot of places. And that situation with 2 trucks driving next to each other on a 2-lane highway or a 3-lane highway, in Europe, I've done enough driving over there, the left one would be arrested in causing the right one to have to pass on the right. So we need to, and I know on this committee, I think we had a bill presented at one time that was going to force slower drivers to keep right, and I think that is something that we need to look at. Other one is a quick one. Can we get copies of some of these presentations? Thank you.
All of the presenters are shaking their head yes, so we will just take that as a yes answer.
Thank you.
Members, we are now out of time. We have to be on the floor in 10 minutes. I apologize. We were unable to get real short ones, Senator Franzen. If we are scolded for being late,
2 seconds.
Senator Franzen.
Thank you, Mr. Chair. I just want to recognize my constituent Brent Boyce here. And also, my questions, I can take them offline, but I'm concerned about cybersecurity and hacking. What's the technology there in industry? And what are you taking into consideration? Not using the cloud seems to be part of it, but just interested in that. And then you mentioned, one of you mentioned the new fleet, that you can only deploy this in a new fleet. I'm just wondering how many fleets are doing this right now and the cost of that in each individual truck, but I can take them offline. Thank you for your time.
Thank you, Mr. Chairman.
Senator Senjum has a yes or no question.
Thank you.
And we will get scolded now, but that's okay. Senator Senjum.
It's addressed to the Cummings representative here. With respect to, carbon emissions and so on, it seems like Cummins is going all electric. Was there any consideration towards hydrogen in any of that thought?
Mr. Foltz.
Thank you, Chairman. So we're doing a powertrain of choice. So electrification in the electrified power business unit is definitely a focus of ours, but we are still going to offer for years to come diesel, hydrogen, fuel cell technology in partnership with hybrid and all-electric technologies.
Thank you.
Thank you.
Gentlemen, thank you very much for coming. I know that some of you have come a long ways, but we really do appreciate the information. It's new to us, and it's really important. So again, thank you very much for coming here on behalf of the Transportation Committee.
Thank you, Mr.
Thank you, Chairman. Thank you, Committee.
We are adjourned.